Lesson 31, Lesson 4.5, Special Product Polynomials. In this lesson you'll see that you have a sum of squares, so that's when you have a plus b and it's squared. Basically, when you look at it like this, you can rewrite the problem like that. Well, when you do all your computation and you do all your distributive property as you did yesterday, your FOIL method, you'd come out to be something like this. Basically, simplified, it would look like that equation there, a squared plus 2ab plus b squared. So when you have a square of sums, you can actually use this equation here to figure things out, and it will actually already be simplified. So your first example, basically what you have here is you have a plus b squared. You needed to put in the values for a and b. So if we look at this, and you're going to use these values here for a would obviously be 3x, and b would be 5. So if you look, they align with one another here. So a would be 3x and b would be 5. Use substitution here. Well, we're going to use that equation as mentioned above here. Everything is solved and simplified. So when you do that, you do your substitution. Put in 3x in for a, square it, plus 2 in for a is 3x, in for b is 5, and in for b squared is 5, and we need to square that. Do all your computation. Well, we have 3x squared would give us 9x squared, plus 2 times 3 times 5 is going to give us 30x, and 5 times 5 would give us 25. So this would be it, simplified. Now you could go ahead, you don't have to do it this method, but basically you can see here that I didn't need to combine any like terms. I could actually set the problem up as 3x plus 5 and 3x plus 5, and I could do my distributive property. After I do my distributive property there, I'd have 4 terms. Eventually, when you do simplify or combine your like terms, you'd get that answer, 9x squared plus 30x plus 25. Biggest thing is if you recognize this, the a plus b squared, where you have a plus b and a plus b, know that you can use this equation here, and then you won't have to simplify. So practice that equation here on your assignment is basically what we're getting to. Again, you have 8c plus 3d. You see the plus sign in there. It is squared, so if you were to write it out twice, you could do that, or you could say that a is 8c and b is 3d. And again, you could use that equation from above. Plug your values in for a and b. When you plug your values in for a and b, this is what we'd wind up, 8c squared plus 2, 8c in for a, 3d in for b, and then we'd have in for b, we'd have 3d, and we'd square that. Do our computation again, we get 64c squared plus 48cd plus 9d squared. Next couple problems, we have a square of a difference. So when you see a problem given when they have a minus b and it's squared, again you're going to use your same technique. Only difference is that when you FOIL things and you simplify things, your equation changes a little bit in comparison to the first equation that you dealt with. So again, first thing I'm going to go ahead and say a minus b, square it. Well, here's what we have there. We have 2x in for a, and we have 5y in for b. Everything aligns like this, even my minus sign. So this is really, we're not going to say that b is, we're not going to say it is a negative 5y. So we're going to go ahead and plug things in. A is 2x, b is 5y. We're going to use that simplified equation for us already. Plug things in, we know, in for a and b. Use your substitution. After your substitution, go ahead and multiply things out, and you would wind up with 4x squared minus 20xy plus 25y squared. Same concept in example 2 here. We have 6v minus 1. I'm going to pull out my a and b values, substitute into this equation. Here's my substitution. After I substitute, go ahead and multiply everything out. and we get 36v squared minus 12v plus 1. The last special product that we're going to cover is a product of a sum and a difference. Now notice, up here we have a plus b and a minus b. When you see that, in comparison to the other two ones that we worked through, is when we had it when a plus b was squared and we had a minus b was squared, we could use those two simplified equations. Notice when we have a plus b and a minus b, we're going to use this equation, which is a squared minus b squared. So again, we look at this, our a values would be that first value there, so we're going to wind up with a 2x, and our b value is going to be 2. So it's just a number there. A is 2x, b is 2. Here's that simplified equation. When you see a plus b parenthesis and a minus b parenthesis, we're going to use a squared minus b squared. Use your substitution. We have 2x squared minus 2 squared. Do your computation. We wind up with 4x squared minus 4. And again, you don't necessarily need to use this equation here. You could actually use what we have right here. So you could use these two and go ahead and distribute, and you'll end up with 4 terms. And then you do your combining like terms, and you would wind up with these 2 terms here. So if you can go ahead and use this right away, it's simplifying your problem right away. You don't have to worry about combining your like terms. Example 2, pull out your a and b values. A would be 4c, b would be 7d. Again, if you look at this problem, it is not exactly like up here at the top where we have a plus b and a minus b. They're just switched around. We have our minus first and then our plus. We can flip-flop these two equations if we needed to. So we're still able to use the equation a squared minus b squared. Substitute in your values. We have 4c squared minus 7d squared, and we'd wind up with 16c squared minus 49d squared. This concludes lesson 31, 4-5, special product polynomials.